Hello guys, welcome to session number 15 or our last session for class 11 KCET one shot revision series 2023. Today's topic will be waves, and as you can see in the bracket it's 1.14, which means approximately one question from every year, and there have been only few years where there have been two questions from this chapter. I'm not going to lie, but this chapter is actually pretty huge. There are a lot of sections, and I have mostly done which is there in NCRT, like the content from NCRT, and a couple extra concepts here and there. But you have mostly I think covered the chapter. You have to just watch the orientation session to know how to approach these lectures. And yeah, so I'll be starting off with terms. As you can see, you have to know these terms, and if you don't, you can just read through the NCRT. One is resonance tube, like what that apparatus is or what that setup is, and then we got wave, we got pulse, then we got harmonic wave, and then period and frequency, and these last two terms have already been talked about even in the previous lecture. So yeah, I'll be moving on to the next topic, which is waves. I'll be a bit quick actually because this is a huge chapter, as I mentioned before. So we know that there are two types of waves. One would be transverse, and the other one would be longitudinal. And the difference is that in case of transverse, the particle moves perpendicular to the wave propagation. As you can see, if the particle is moving like this, the wave is moving like this. So it is like perpendicular. If you see, it is perpendicular. So that is transverse. And the example is more important. String is transverse wave, and we got sound wave as longitudinal wave. And in case of longitudinal wave, what happens is the particle moves along the wave propagation direction. So if the wave is moving like this, as you can see, the particle also moves along with it. So and here is like a basic formula which you might know, which is frequency is equal to c by lambda. So this is like a basic formula, but I've just mentioned it along with waves because it would have been done in class 10, I'm assuming. So next topic would be wave equation. So here is like the wave equation: y is equal to a sine bracket omega t minus kx plus phi. So if you're wondering what the terms mean, you can just go through this box from the NCRT. Every single term has been explained. So yeah, and next term would be k over here. So k is nothing but wave number, by the way. So as you can see, angular wave number. So the formula is important. K is equal to 2 pi by lambda, where lambda is the typical wavelength. And finally we got this formula which is v, which is also called as wave speed, by the way. So wave speed is equal to omega by k, where k is the same angular wave number from above. That is like wave equation about wave equation. So next topic will be wave direction. So if you're wondering how you have to know about the direction of the wave, it is simple. If the sign of omega t and kx are opposite, then the wave is always moving in the right direction. As you can see, it's moving in the right direction when the equation is like this. As you can see, omega t is positive and kx has negative sign, or it can also be like omega t has negative sign and kx has positive. Basically they should be having the opposite sign, and then in that case the wave is moving in the right direction, and it will be moving in the left direction if the signs are the same. So as you can see, y is equal to a sine omega t plus kx, both have positive sign, or it can also be a sine minus omega t minus kx, both have negative sign. That is about wave direction. Next one will be phase and path difference. So as you can see in this diagram, there are two waves, like wave number 1 this one, and wave number 2 is this one. So I've written the equation. Let's say wave number 1 has y1 is equal to a sine omega t minus kx plus omega plus phi as its equation, and let's say wave number 2 has equation a2 sine omega t minus kx2 plus phi. In this case, if you want to know what the phase difference is, then it is delta phi. As you can see, delta phi is phase difference, which is phi 1 minus phi 2. You have to know that the entire term over here is actually going to be phase. Like this entire term is going to be the phase. So this is phase 1, and then this one is going to be phase 2. So please do keep it in your mind. So when you subtract that to get the phase difference, you'll be getting basically k times x2 minus x1. So I'll be just writing it. So as you can see, x2 minus x1 is nothing but path difference. So what is phase difference? Phase difference is the entire this term subtracted by this term, which will make you get this. So I'll be writing one formula is delta phi is equal to k x2 minus x1. And what is x2 minus x1? x2 minus x1 is nothing but path difference. As you can see, I've written path d, which means path difference. And I've already mentioned k is angular wave number, which is 2 pi by lambda. So that is so this is like the second equation, where as you can see, k is nothing but this, and this entire term x2 minus x1 is this, and this is obviously the multiplication symbol, because over here I put bracket, over here multiplication symbol, and this is the diagram. You can just go through the diagram. And the next part would be velocity and acceleration of a particle in a wave. So let's say I've taken this particle A. If you want to know what its velocity is, then obviously in a wave, like in this wave, every particle follows SHM. And from my previous lecture, simple harmonic motion, you can watch it. The wave velocity of that point which follows SHM will be omega a2 minus y1 a square minus y square whole under root. And this directly these two, and acceleration would be minus omega square y. Both of these are the SHM formulae, but this is for a particle. Particle name is A. As you can see, this particle is called A. And it can also be written as acceleration of point A is equal to partial differentiation of velocity of A with respect to velocity of t. This is from kinematics, but this partial differentiation, so it's not the normal differentiation. As you can see the symbol. Then we got particle position. So this diagram, which is from Edunity's channel, I've given the credit. It shows you how to get to know the particle the position of the particle. So there are two methods. Method number 1 would lead you to memorize this formula, which is velocity of particle is equal to minus v into slope. So as you can see, the point over here p1, the slope is negative. Like if you draw its slope, you might know how to draw the slope. It has been taught in 10th grade. This angle, if you see, it's negative. Tan, I think it would be around 135 or something, which is negative. So if slope is negative and the formula already has negative, velocity of particle would be positive, which means it would be going in the upward direction. As you can see, it's going in the upward direction, and it would be going in this direction. So this would be the position of the particle. And method number 2 would be just to draw an image right after small time dt of the wave. So that's what the image over here has been depicting. if you see the dotted line is the wave position after small dt time. So this could be drawn by any person because it's like imaginative. And if you see, once you draw the dotted line, the particle would have come somewhere around here after a small time dt. So that is method number 2. So both the methods have been like written over there. One needs formula and the other one doesn't. Next one would be string waves. So what's the formula for string wave? Velocity of a wave in a string. If you see this diagram over here, this is like a setup where the string is attached to a body of mass m. Please do note that the body mass is capital M and the string mass is small m and the string length is L, capital L. In this case, the velocity of the wave, as you can see, which is going upwards, is going to be given by this formula. V is equal to under root tension by mu, where mu is nothing but linear mass distribution, which is mass per unit length. And in this case, this would be small m. So please do pardon me, small m divided by L, because that is the mu is going to be linear mass distribution of the string. So tension anyways, as you know, would be capital mg. So when you replace it, you'll be getting basically what would be the equation. If you replace t, it would be mg. And please do pardon me for the bad handling. I'm using a mouse right now, not a writing pad. And this would be m by L. So obviously this L will go to the top and you'll be getting this formula. The final formula would be mgl by small m under root as the formula. But this is only in case of this setup. Because this setup is hanging, we have tension. If not, then you should be using the normal formula under root t by mu. So that is about, this basically like a question itself. In CT, this might come as a question itself. So you have to know that tension should be equated to capital Mg. Next one would be average pressure and intensity. So the formula would be this. I know the formula is huge and stuff, but I would recommend you to do one thing. You can either just notice the proportionality, like P average is directly proportional to square of omega and square of amplitude, and is just proportional to all of these. And you can do that, or you can just memorize the formula. I had memorized the formula. You should just like wake up and write a couple of formula every day, and you'll be able to memorize actually. And intensity is nothing but the same formula, but it's divided by seconds, which is P average by seconds. So the formula would be this. As you can see, same formula as above, but it would be divided by S. So the S would be S would not be there. And by the way, I think I told S as seconds, but please I'm sorry, S is not second. S is area. I'll just write it over here. S is surface area. So I'll just write S is surface area. It's not seconds. Surface area. Yeah, I certainly do hope I'll be able to buy a writing pad one day. So surface area, as you can see, S I've written over there. Next one will be superposition. So let's say we have a string and this is like one wave and this is another wave. This has amplitude A2 and this has amplitude A1. Then when they like superimpose, this would be the final wave, and the amplitude of it would be A1 plus A2. So that is one formula. And the second formula is, let's say this is one wave, it's like going up, and the other wave is coming from down. In this case, when they superimpose, they'll cancel each other and it will be a small wave. This is like a large wave, this will be a small wave, and that will be A1 minus A2 or A2 minus A1. It depends on which is large or which is small. And let's say if A1 is equal to A2, then obviously when they superimpose in this case, they'll get cancelled and the displacement would be equal to 0. So that is like an obvious fact. Next one would be, because A1 minus A2 is equal to 0. And next one would be wave reflection. So this is there in NCRT, and if you see, there are two cases. Case number 1 is when it's fixed. So I'll just highlight fixed. Case number 1 is when it's fixed, and I have depicted fixed as a single dot, and I've depicted loose end as a circle like this. So if you see a single dot when it's there, it's fixed end. Let's say the initial wave equation, as you can see, yi means initial. So it is a sine omega t minus kx, and that is when the wave is going like this in this direction. So once it hits this fixed end and it reflects back, it will reflect like this. As you can see, I've put implies after the reflection, it will become like this, and it will be moving in this direction. So that means the y reflection formula would equation would be a sine omega t plus kx plus phi. And if you see, the direction has changed. That's why the symbol, sorry, the sign of both of these are the same, plus plus, from the part where I mentioned about the signs. And there's an additional plus phi. So I just underline it because the phase difference would be phi, because this is going like this is like this and this is like this. So that's why this phase difference phi has come into the picture. And the next case would be, as you can see, when this is moving like this, like when it's moving like this wave, and it hits a loose end. This is a loose end, or a free end basically. It's also called as a free end. And when it hits this free end, it will go back like this. It won't be like how it was like in this case. It will go back like this itself. So that plus phi term won't be there. But other than that, the sign will obviously change, because now it's going in the left direction, and the signs of these two should be same. This is why I told you that the sign of direction of the wave is important topic I had mentioned above. So that is like coming into existence now. So as you can see, yi initial would be a sine omega t minus kx, and y reflected would be equal to a sine omega t plus kx. And the only thing is the sign has changed because it's going in the left direction. There is no plus phi because the side on which it's there is the same, like not the side, the direction. As you can see, it's upward itself, the wave. Even this is also upward, the pulse actually. So anyways, let's go to the next topic, which is standing wave. So standing wave, I have created two slides, as you can see over here. So both of these have been taken from EduNiti. I was not able to write this, so I just thought of using it from his channel, so I'm giving him the credit. As you can see, standing wave looks like this. I'll just tell you what these symbols mean. This means node. So this is called as node, and this is called as anti-node, the one at the topmost point. This is also anti-node. This is also anti-node. So that is, and this is obviously once again node. So you have to know what an means and what n means. So the important point over here, like very important point, is the distance between one node to another node is going to be lambda by 2. Please listen to it carefully. And the distance between anti-node and node would be lambda by 4. So if this is clear, then the upcoming part of the lecture will be very simple. So as you can see, the distance between this anti-node, like this anti-node and node, is going to be pi by 4. So I'll circle this too. I'll be circling this too. So as you can see, pi by 4. And the same way, the distance between this node and this node is pi by 2. This is pi by 4 by the way. I think I told pi by 2. Please do pardon me. So the points over here, the same thing has been written. All points between two successive nodes are in the same phase, which means between this node and this node, all of them are in the same phase. Even this is all of them are in the same phase. Like this is, as you can see, this is in the same phase and this is in the same phase. So that's what it means. That is point number 1. Point number 2, all points across a node are in opposite phase, which means across this node, this and this node, the points across a node are in the opposite phase, which means delta phi would be equal to pi. And then separation between two consecutive nodes or antinode is lambda by 2. It's just what I mentioned. It has been written over here. And between consecutive nodes and antinode is pi by 4. Not pi by 4, lambda. If I've told the wrong terms, then what's written, it's obviously my mistake. Please do not write that in the notes. You have to just write whatever is written over here. So the next part, it would be standing wave equation. So this is the equation for standing wave. It is y is equal to 2a sine kx plus omega 1 sine omega t plus phi 2. And in this case, this entire term, like this much, as I've written over here, this entire term is nothing but the amplitude of a point at a distance x. So listen to it carefully and write it that way in this case. So we got case number 1 and we got case number 2. Obviously the diagram numbering is related to them, so I'll just draw the arrow. So for case number 1, when phi 1 is equal to 0, basically when this is equal to 0, what will happen is this will be the new equation. And when the equation is like this, as you can see, when the equation is like this, at x is equal to 0, it would be a node. And let's say we go to case number 2, when phi 1 is equal to pi by 2. In that case, this would be the new equation. If you would have learned trigonometry by now, I think, and this would be fairly obvious. And when this is the case, at x is equal to 0, there would be an anti-node, and it would look like this. The wave would look like this. The dotted line means the other possibility, by the way. So yeah, that's, I think you already know what the dotted line means and stuff. So next part of the chapter is very important, and I have written it in the most creative way. Like I haven't seen anybody write it in this way, so I've written it in this way. It might even seem confusing to students, but I think this personally, I personally think this would actually help a lot, because you have to read the title carefully. From now, whatever I'm saying, please listen to it carefully, and you'll be able to understand. So SW means standing wave, and in BE, which means both ends, you have to note that BE means both ends, and bracket C means closed, and bracket O means open. So standing waves in both end closed string or both ends open pipe. So both of these have a very similar formula. That's the only reason why I have written these two in under one case. Usually what people do is they write the string case and then they write the pipe case. But if you look closely, the formula is the same. So let me go slowly over here. Nth harmonic or n minus 1th overtone. As you can see, I'll be this is the main formula, by the way. I've written one formula which would be easily enough for everything actually. In case of SW, which means standing wave in both end string. Note that I'm doing both end closed string. Right now I'm doing both end closed string. Please listen to me carefully. So in that case, it would be FBE bracket N, which means frequency of both end closed string, and N, because obviously this is only for N general. This is general, right? This could be a general formula. Is equal to N by 2L under root T by U. This is basically nothing but velocity in string. I'll write it as STR. Do you remember I mentioned above that velocity string would be under root T by mu? This is the same formula. So I think if I would just underline it because it might be confusing. So this entire term over here would be this velocity of a string. So n by 2L under root T by mu. So if you are asked what is going to be the first harmonic, in that case you have to put n as 1. So when n is equal to 1, it would be 0th overtone. 1 minus 1 is 0, right? So first harmonic or 0th overtone. First harmonic is also called as fundamental frequency, by the way. You have to know this. That's why I've mentioned it. In that case, the formula would be, when you put this as 1, it would be 1 by 2L under root T by mu. I'm sure this is like obvious. And the same way, actually I will keep this as it is. And the same way, if you put n as 2, that would become second harmonic. You have to just put it over here, by the way. N is 2, it will become second harmonic, or it would be 2 minus 1th overtone, which means it would be first overtone. That's why I've written or first overtone. In that case, this 2 will get cancelled and the formula will be 1 by L under root T by mu. So yeah, that's about the formula. It's a very simple formula, and these two are the examples. Please do note that this is example number 1. I'll just write EX, and this is example number 2. In this example, we have taken n as 1, and in this example, we have taken n as 2. And what is this diagram? This diagram is nothing but both end is closed, both end closed string. This is case number 1. This would be when n is equal to 1. There is only like one, as you can see, one wave is drawn. And these two are nodes, by the way. As you can see, this is node and this is a node. So because both of them are nodes, the length between this point and this point would obviously be L is equal to lambda by 2, because I did mention above that distance between nodes is always lambda by 2. And in case of this, what would happen is the distance between one node and one node is lambda by 2, and the distance between this node and this node is lambda by 2. So lambda by 2 plus lambda by 2 is nothing but lambda. So length is equal to lambda. So I hope this is clear, because if this is clear, then this would also be clear. So in NCERT, what we have is we have another example where it is both end open. So you have to know that both end closed string, and both end opened pipe have the same formulae. The only difference is, as you can see, I'll just highlight the formula. So this is the whole formula. I've just like nth harmonic or n minus 1th overtone is equal to f both end is equal to n by 2L Vg. So I'll tell you the difference, as you can see over here, would be n by 2L is the same, but because this is not a string, we have to not use this t by mu under root. We have to use vg instead. And what is vg? I'll be mentioning at the bottom. For now, you can just write this in your book. So obviously, I've written the same cases over here. When both end is opened and when n is equal to 1, it would look something like this. And this would be the dotted line, like this would be the wave. And if you see, the length is pi by 2, sorry, lambda by 2. I don't know why I keep saying pi. It's lambda by 2. And the reason is because the distance between one antinode and the other antinode would be, it would be lambda by 2, by the way. And in this case, as you can see, when n is equal to 2, this distance, oh, I think I've written, please make this length is equal to lambda. Length is equal to lambda when n is equal to 2. So all you have to do is, you have to put n as 1 over here if you want the first harmonic or zeroth overtone. And you have to put n as 2, just like how it was in this case, if you want second harmonic or first overtone. So whenever you replace n, you have to replace it over here also and pronounce it, like say it the same way. So I hope that was clear. As I mentioned, this chapter is pretty huge, but I've like put it in a very good manner, I think. Next one would be, next heading, read it, like please listen to it carefully. It is SW, which means standing wave in open end bracket closed string, where this is one end. Or here it was, if you remember, it was BE, which means both end. Or here OE means one end. So standing wave in one end closed string or one end closed pipe. So what the summary over here is, the formula would be the same when both the ends are closed of a string or both the ends are opened of a pipe, and the formula would be the same when one end is closed of a string and one end is closed of a pipe. So that's why it's 2 2, or there it was 1 1, like this number over here, this numbering. So the formula, as you can see, would be 2n plus 1th harmonic or nth overtone. Please don't mind me like stressing on the th while pronouncing. It's just so that you students will be able to understand the importance of the way you say the entire thing over here. And as you can see, FOE, which means open end, n is equal to 2n plus 1 by 4l under root t by mu. So what you have to know is, this over here is nothing but wave velocity of a string, just like how I've written above. I'll just write it again, STR. STR. That R doesn't look like an R. STR. So this term, what you have to notice, 2n plus 1 by 4l, because that is common. Above, like in the above case, it was n by 2l, which was common. Or here it's 2n plus 1 by 4l, which is common. So obviously I've written, like example, I've taken example number 1, and we have another example number 2 over here, just like how I've taken above, so that you know how to apply this. Or here, by the way, n would start from 0, because if you put over here as 1, it would not, like if you start from 1, then it would be a problem, because over here it would be 2 times 1 plus 1, which is third harmonic. How can something be third harmonic in the beginning? That's why you have to start with n is equal to 0. So when you put n is equal to 0, it would be first harmonic. And once again, first harmonic is fundamental frequency here. So first harmonic is nothing but, as you can see, first harmonic is nothing but fundamental frequency. And what is first harmonic formula is when you put n as 0. So the formula would be 1 by 4l under root t by mu. And yeah, this is the one end open, one end closed string, open like OEC, which means one end closed string. So one end is closed, which means this would be a node and this would be an antinode. So as mentioned above, the distance between a node and an antinode is lambda by 4. And in case of second case, you have to put n as 1, right? Because you put n as 0 here. Second case, let's take n as 1. So when you take n as 1, it would be 2 times 1 plus 1, which is third harmonic, or nth overtone, which means second, or n as 1. Like if you put n is equal to 1 over here, then it would be third harmonic or first overtone. So that's what I've written for example number 2, when you put n as 1, third harmonic or first overtone. So for that, the formula would be, instead of 1 over here, what will happen is, when you put n as 1, it will become 3. So the formula would be 3 by 4l under root t by mu. And that formula is for third harmonic or first overtone, when basically n is equal to 1. So I hope that was clear, because if that is clear, then the next part would be very simple. So yeah, over here I've taken, I've drawn the diagram. This would be node, this would be node, and this would be an antinode. So length of this entire thing, length would be obviously 3 lambda by 4, and this is for n is equal to 1, by the way, example number 2. So the same way, one end closed pipe, like this is a pipe, and when one end is closed, it would be the same thing like how it was over here, in terms of formula, that is, as you can see, 2n plus 1th harmonic or nth overtone is equal to FOE, one end, is equal to 2n plus 1 by 4l Vg. So it's the same thing, like 2n plus 1 by 4l, that much is the same. But here, because this is a pipe, it's not a string, instead of using velocity of string under root t by mu, we'll be using Vg, and I'll be telling what Vg is in the bottom in just like about a couple more minutes. So the length, obviously, over here I've written lambda by 4. It is because this is a node and this is an antinode. So the distance is lambda by 4 between node and an antinode. And the same way over here, node, antinode. So lambda by 2 plus lambda by 4, which is 3 lambda by 4. So case number 1 is when you put n is equal to 0. So that would be first harmonic or 0th overtone. Formula would be 1 by 4l Vg. And when you put n is equal to 1, you'll be getting third harmonic or first overtone, which is equal to 3 by 4l Vg. If you have listened to that carefully and if you have like made note of those two, you'll be able to understand. Yeah, with that we have covered the most important part of the chapter. Next one would be displacement and pressure waves. So these are the formulae. This is pressure wave, by the way. You can just copy it down. P is equal to P naught cos omega t minus x by v, and P naught over here is nothing but bulk modulus omega by v s naught. And what is s naught? S naught is from this equation, s is equal to, which is displacement wave, by the way. This is displacement wave. S is equal to s naught sine omega t minus x by v. So those are the formulae, not very important, but yeah, included. Next one would be sound waves. Over here, I'll be first, like the very first thing that I'll be doing is highlighting the formula for Vg. So the reason why I didn't like write this under root gamma p by rho is because it is a huge term and it can also be written in another fashion. So instead of writing that this entire thing over there, I just wrote as Vg. But for string, it is just one formula under root t by mu, so it's easy. So instead of writing VSTR, I just wrote the entire VSTR formula itself. So what you have to do above is you have to note that Vg is equal to under root gamma. Gamma is the same constant, by the way, where it is Cp by Cv. P by rho. Rho is density, which can also be written as gamma RT by m. M again is mass. So yeah, another formula for sound wave is going to be when it's S means V solid, by the way. V in solid is equal to Young's modulus rho under root. This y over here is Young's modulus, has been done in elasticity. VL is nothing but bulk modulus by omega. So that's why capital B by, not omega, by rho, where rho is density. And what is beat frequency? FB means beat frequency, which is equal to modulus of F1 minus F2, which means no matter what you do, it should be a positive. Like it could be F2 minus F1 or it could be F1 minus F2, but it should be a positive frequency, because frequency can't be negative in that case. Next one would be Doppler's effect. Very important once again. I have written this Doppler's effect over here in the most simple fashion ever. Like the easiest way to remember Doppler's effect. All you have to do is you have to remember this formula, which is F apparent is equal to F naught bracket V plus or minus VO and V plus divided by V plus or minus VS. Or here you have to just keep it in your mind that O is observer and S is sound. Please do not get confused. You have to know this abbreviation because here is a sign convention. The sign convention is very important, and this is the part where I made it easy for students. That's why I'll put it in a box, like something like this, in this kind of a box, because this sign convention is not used by like anybody else, I think so, or they have their own ways. But this was my way of keeping myself, know about the sign convention. So as you can see over here, this is O observer. If the observer is moving towards the sound, like the object which is making the sound, then the sign should be positive. So which sign are we talking about? We are talking about this sign, obviously, because O is moving. So when O is moving, we are talking about the sign of this part, and when S is moving, we are talking about the sign of this part. So let's take case number 1 when O is moving, which is when observer is moving. So when observer is moving, we have to take it as positive here, which would be V plus VO. But if observer is moving away from S, like in this case observer is moving towards S, but if observer is moving away from S, then it should be negative, which means V minus VO. Don't worry, I've taken examples if you are not able to understand. You have to watch this part many times to understand what I'm saying. Second case over here would be when observer is like stationary, but when S, which is sound, is moving towards the observer, then the sign would be negative, which means V minus Vs. But if sound is moving away from observer, then it would be positive sign, which means V plus Vs. So that's the sign convention. Now let's apply it on two problems, which is from EduNity's channel once again. So over here, let's say that there is a source, which is obviously going to be stationary. Usually source will be stationary. So because this is at, like source will be stationary, but the sound direction is like this. So please do listen to me carefully. I'll be using this rainbow color. So Vs is going like this. As you can see, he has also put an arrow. And if you see observer is going like this. So now let's write the formula using my sign convention. So the formula would be F apparent is equal to F naught bracket. This is the important part. V. Now let's see what is happening. Over here, the observer is moving. Like for the above case, we have to, like for the top part of the formula, we have to see whether the observer is moving or not, because it has VO. So what is observer doing? Observer is moving towards S. So that would be case number 1 over here. Observer is moving towards S, which means positive. So that's what has happened in this formula. As you can see, it would be V plus VO. Now for the bottom part, we have to check what is happening with the sound. So what is happening with the sound? The sound is moving towards observer. It's moving towards observer. As you can see, it's moving towards the observer. So let's go back to my sign convention. When the sound is moving towards the observer, it will always be negative. So V minus Vs. So this would be the formula, and I will be just putting a box like this because you have to apply it for these two cases to get a basic understanding of how to like apply the formula. So I hope you understand. And by the way, why is this not working? Okay. Just give me a second. So I'll be putting a box as I mentioned over here. And now let's move to example number 2. I'll be erasing this. Example number 2, the same way, let's do it for example number 2 together. So as you can see, the source, this is the source. Let's put a box. So the source is going like this now. Or actually, what am I doing? I really apologize for such stupidity of mine. So over here, this will be case number 2, right? Case number 1 is already done. So let's move on to case number 2. So let's put a box around the source. Now the sound is moving like this. As you can see, Vs is now in this direction, which means the speaker is like set to the other direction, to the other side. So Vs is like this. And over here, if you see, observer is moving like this. So now let's write the formula together. I'll put a box around it. So let's write the formula together. F, where F is frequency, by the way, I think you know already. F apparent is equal to F naught bracket. Now this is the important part. So let's see, the above part is when you have to check the observer because it has VO. What is the observer doing? The observer is moving away from the source. He's moving away from the source. He's running away from the source. So let's see what happens when observer is moving away from the source. If observer is moving away from the source, the sign is negative. So that has happened over here. V minus VO. So the sign has been negative. Now let's see what's happening for Vs. What is the sound doing? The sound is going away from the observer. It's moving away from the observer. So when sound is moving away from the observer, let's see what happens to the sign convention. When sound is moving away from the observer, as you can see, when sound is moving away from the observer, sign is positive. So that means the sign over here is positive. So yeah, you can watch this part many times if you are not able to understand. But in such a short space, I have like taught Doppler's effect for sound. For light, I'll be doing it in class 12 chapters. So with that, I've completed this huge chapter waves in the shortest manner possible and explaining everything. So this would be quite long, but please do note that I've done like a lot of it. As you can see, I've even explained each and everything along with examples and everything. So yeah, for so much work, please do like the video, subscribe to the channel, and please do share it with your friends. It will benefit the community as a whole. So with this, we have completed class 11 chapters, all of them. I will consider class 12 chapters on like whether to start with the series or whether to complete it properly, whether to upload all the chapters. But yeah, I think this was a long lecture and obviously the last one for class 11. You can join the Telegram group in the description. Please do work hard. All the best. See you.